Alright, ladies and gentlemen, the first thing we're going to talk about today is solving square and cube roots graphically. So in our notes here we have two sides. We have the square root of x minus 1. We're going to make that, can't write in white, can we? Make that y1, and then we'll make this y2. So y2 is just going to be 3 all the way down because it's y equals 3, right? So horizontal line at y equals 3. Our y1 is going to be the square root of x minus 1. So normally, square root of x, we got 0 and 1 and 4 and 9. Well, the minus 1 moves everything to the right one. So instead of being at 0, 0, now it's at 1, 0. 2, instead of being at 1, 1, now it's at 2, 1. So we got 1, 0, 2, 1. The next one, instead of being at 4, 2, it's now at 5, 2. Instead of being at 9, 3, now it's at 10, 3. So as you can see graphically, they intersect at 10, 3. Got the same y value, same y value. Now, solving algebraically, we've got these 4 steps here, and really we're going to spend a lot of time doing this tomorrow, but it's still important. Okay, so solving this algebraically, got to isolate the radical, did that, raise the appropriate power, so we're going to square both sides. So we get x minus 1 equals 9. Solve, so I'm solving for x, this is algebra 1, really easy, x equals 10. Look at there, 10. Boom, boom. Coinkydink? I think not. So that's really what we're going to be doing a lot of. There's another example of graphing. If you want to, you can do that. I'll just go ahead and solve it algebraically, and maybe you can get it as far as graphically goes. We square both sides, so I get 4 equals x over 2. I multiply both sides by 2, and x is going to be 8. So this is going to be our solution. See if you can get that. Next thing, I'm not going to do all these problems because there are a lot, and they're just kind of redundant. So on number 4, you square both sides. I get a plus 100 equals 625. That's because we're squaring both sides. Subtract 100, so I get a equals 525. And then the check for extraneous part comes in when we take this number and we plug it in and see if it makes the statement true. And sure enough, 525 plus 100 is 625. Square root of 625 is 25. Now on number 5, I'm going to subtract 3, so I get the square root of 2x minus 1 equals negative 3. Now when I square both sides, I get 9 equals 2x minus 1. Now it's a little more complicated algebra 1 problem. Add 1, divide by 2. So x is 5. Now if I take 5 and put it back in, I get 10 minus 1, that's 9. So the square root of 9 is 3. I get 3 plus 3, which is not 0. So that means this is an extraneous solution. So x solution. So that means there is no solution. That means no matter what number I plug in there, I add 3, it's not going to be 0. Okay? So that was one of the ones that has an example of an extraneous solution. Number 6, you subtract 1, then divide by 4. Subtract 1, then divide by 4. Number 7 and 8, anytime you got square roots on opposite sides, we can just square both sides. So I get x plus 3 equals 2x minus 1, and then we're just bringing the baby to the mama. So I got 3 equals x minus 1, so x is 4. And we plug it back in, we get 7 and 7. Okay, so that's that. Cube root, the only thing difference here is instead of squaring both sides, we're going to cube both sides. So on number 9, PEMDAS backwards, right? So we add 4. I get 14. Then I divide by 2. And I get 7, then I cube both sides, and I get 343. Subtract 2, so x is 341. And we always double check, plug it back in. 341 plus 2 is 343. Cube root of that is 7. 7 times 2 is 14, minus 4 is 10. Okay, so that's how all those work. The last couple review of last time, anytime you got the the exponent power with a fraction, that just means square root. And so for number 11, that other one to the left, that would be cube root. So then we divide by 2 first. Square both sides. Square both sides, so x is 41. Cool. Good luck. See you next time. Bye-bye.